Aloha and welcome to the Solar Coaster Show here with my co-host Jason Verkart as well as Troy Morgan from Adapt Energy.
Adapt Energy being the product itself, but Pantech Design being the company that built it.
I got it. Pantech Design, the creators of Adapt Energy. Is that the one?
Perfect.
Okay.
Yeah.
It was escaping me there for a moment. Well, welcome to the show. It's so good to see you, my friend. Calling in from Texas. Where are you in Texas?
So we're in Dallas, Fort Worth. If you're not from the area, but if you are, it's like right near the airport. So maybe 10 minutes away from the airport, right in the middle of Dallas and Fort Worth, the major cities.
Gotcha. And Jay and I were talking earlier this week, and we're like, who do we know in Texas with everything that's going on? Well, of course, we know Troy and Megan and all the great people over there at Pantech, so we got to talk to them. Jay, how you doing today, buddy?
Good morning. It is cold in Osaka, but I'm not going to complain about it because Texas is doing no better at this point.
Very good, very good. All right, so Troy, we are very interested to get better acquainted with what's going on in Texas. As I understand it, we're just talking to Megan, your staff member, good friend, longtime contributor and friend to the Solar Coaster as well. And apparently they're seeing outages and all kinds of, I think you called it the event, as if it were kind of like a once-in-a-century kind of event. What's going on?
We certainly hope so, right?
Yeah, definitely, certainly hope so. But it is. It's like it's a major, major event. I mean, the last time we had anything even remotely close to this was in 2011, and that was like a tenth of what we're experiencing here. I mean, the simple part of it is that we had over 4.5 million people out of power in the middle of probably the coldest. I think record cold was recorded on Wednesday, I think Tuesday night or Wednesday morning at -2 where we are, and a sort of wind chill of like -15. That's big time. And Texas, we're special, right, about our power and our energy and all that in terms of the fact that we have our own grid, but we were not prepared from a grid operator standpoint to handle the demand, but the loss of generation as well. That's what happened.
Yeah, and we're gonna dig into that a little bit to get a better sense of kind of how that individual separate grid kind of became a reality, and then also, and to a detriment at the moment, and then also better understand, what's going on with Pantech Design and your system. Obviously, you're on camera, you're sitting there with R2-D2 in the background, and you're all of your equipment humming and buzzing. So you've got power, and that doesn't surprise me, Mr. Morgan, because of what you do for a living. So for people that haven't tuned into the half dozen or so shows that we've done with you in the past, why don't you give us a quick intro, give people a sense of what it is that Troy and Pantech and Adapt does.
Yeah, so Pantech Design's a 16-year-old company. We started working on, or really designing and engineering large-scale home automation, building automation, and yacht automation systems. That's what we've done for many, many years. But about 3 years ago, we started working on energy-based control systems. And from there, we began the development of our own energy control system. It's called Adapt Energy. Its goal is to it does a lot of things. It monitors, it controls load, it shapes and shifts that load based on different circumstances and events in the home. And then it can even tie to the home's automation system, so that those different events, whether it be a grid loss or severe weather or whatever, could just be scheduled event, can control things like lighting and shades and climate. And so, tying all that together, you really do have the holy grail of an energy management and monitoring system.
And when you said 3 years, it's like I think we've kind of known you for about 3 years.
Been that
so
long.
We got lucky, and we kind of caught you just as you got into this space. Probably met at SPI or something like that, I suspect. It's looking back on that, we were thinking about scenarios that would allow this technology to really shine. and and we did something called the Pantech. When I say we, I mean G and J did Pantech Design Minutes on multiple radio shows throughout like a 6-month period, and we were exploring in these little nugget size kind of bites how this home energy automation kind of moniker could take shape. And then we had one which was specifically a storm hits and what happens inside your home and what type of events take place. And well, lo and behold, you have this once in a whatever century, half century event that you're living through right now. So you're living out the Pantech Design Minute at the moment. So I really want to understand the scope of what's happening, but I don't want to jump on Jay here. Jay, is there anything you'd like to just jump in right away out of the gate? I start talking and forgetting.
No, that was exactly it. And we were talking about it before the show. I was like, didn't we discuss this exact scenario? It's so odd to have this played out in front of us as in the real world. And then I really want to hear from you what your perspective is as to what did you notice? Did you notice anything? Have you had to take any real action? I mean, I know your system in particular is very, very well tuned to your lifestyle. So I can't imagine that you've had to do much, but I want to know what the hiccups, because this is the first time as far as I know, that it's been truly tested real world.
Yeah, what happened, Troy? I mean, that's just the bottom line, right? What happened when this storm hit? What was it like in the Morgan household?
Well, first of all, the fundamental thing that I didn't really give credit to was peace of mind. I've said it before. Yeah, it's cool that I have a solar and home battery and Adapt Energy, sort of paying attention and in control of all of it and making it all and be perfect for our lifestyle, like Jay said a moment ago. But here's what's interesting: you have no lifestyle in a situation like this. Your lifestyle is more basic than you ever dreamed it could be, right? So having running water becomes a real luxury. Having heat because you have power, a luxury. And so what I found early on is that the peace of mind that I have and have for my family is huge. I was thinking about this earlier today, and it sort of comes down to, like, you can equate it to how you would look at insurance. People don't buy insurance for their homes and their cars because they know something's going to happen. You buy it just in case, right? So sort of the same principles apply when you start looking at energy and then this whole event thing that occurred. We're lucky, but are we really lucky? No. We were intelligent and smart to recognize that someday, something, whatever it is, our grid gets hacked, we have a major storm, whatever, we want to be in control of our own destiny with respect to our power, but also have that peace of mind. And so we definitely changed our lifestyle through this. We had to, but we had to make far less difficult decisions than anybody else, because we had power and we had a system managing that situation so that we would have power for an extended period of time if we lost grid power.
Gotcha. Now, help me understand. You said something like 4.5 million people were out of power, and actually, I don't have a good sequence or a good kind of chronology on this. So, is this just like the last couple of days, last week? How long has it been? Is it affecting all regions? Why is it Texas? I mean, you mentioned the grid, right? So, is it everybody? What's going on out there, just in general?
Yeah, it was everybody. And so if you look at the chronological order, we started receiving our first major snow. Before it was just flurries, but major snow happened on Valentine's Day. So Sunday, February 14th, we had a major snowstorm event, which for some people, when I say this, they're going to laugh. And hey, I'm with you. I lived up north and I lived in Alaska, and I get it, right? So a major event, we got 4 to 5 inches of snow.
Yeah.
Okay.
I do want to tell you, I mean, the one time I did one cross country journey, it's the only time I've ever been to Texas, and we were crossing across up the top there. But crossing the border, I got a picture right there, welcome to Texas, with a big sign, and there was snow on the ground.
Yeah.
So it's not like it's completely unusual
Mhm.
to see snow in the wintertime, but this is still 4 to 5 inches when you don't usually see it, and people have bald tires and don't know how to drive in it and all this other stuff.
Yeah.
It can make life difficult.
Yeah, and if you're driving across Texas, if you've done that trip, that's almost a day to get from one end to the other, right? Going east to west or west to east. So yeah, I mean it's a big state, right? So started on Sunday, and by about Sunday night, because of the cold, so you have snow, but snow is no big deal. 30 degrees or whatever, that's okay. You can deal with that. What really got us was ahead of the snow, we had 3 or 4 days of very, very frigid weather. So what that did was that sort of froze the ground, froze everything, and sort of prepared it to stay cold for an extended period of time.
Wow.
Then you dump snow on it, and now all of a sudden you've got some really interesting problems, especially with respect to the T&D, or the transmission and distribution of the grid, and the substations and all the different methods of generation. They were dropping offline like crazy because they're not prepared for those types of temperatures. And so ERCOT, who sort of manages they're basically the grid operator, they decided, and we're within minutes. This is a really interesting thing. We were within minutes of having a total grid failure, which would have taken us about a month to recover from and bring everything back online from. Think about that. We were minutes away when ERCOT finally said, okay, we're done here. We've got to start shutting things down. So it was a combination of two things: demand continuing to rise, but more importantly, generation dropping offline like crazy. And it's not just the windmills, and you're going to read all kinds of crazy articles. It's everything together not working well. And that's why we ended up with being told they're going to have to institute rolling blackouts. Those rolling blackouts turned into total blackouts for people for 3 or 4 days.
So
and
what did that look like for people? I mean, they would get a message and say there's going to be a blackout in your area. Prepare. Yep. I read a couple of articles suggesting that there were some price because of some type of new pricing structure or supply demand kind of regulation.
That's even a second issue, Josh. There's a wholesale. My understanding is it's a
gritty
company because it's kind of an open market. You have multiple choices of where you buy your power from, and the one company that we're talking about had a base subscription fee of like $9.99 a month, and
right.
Then they would allow you to buy power at wholesale rates, which gets you into, I mean, you're playing with the big boys, buying stuff at wholesale, and generally that's going to, I mean, it's like going to Costco. You get some stuff at a discount that way, and for the most part, I think it's a nice system to get smaller folks into that market and get them a good deal. The problem is when these plants all start going offline, the price of wholesale electricity on this open market shoots through the roof because there isn't any to buy. I mean, it's just a supply and demand problem. Yeah. So it went from like, what was it, Troy? $50 a megawatt
so like
hour.
$2,500 a kilowatt hour.
A kilowatt hour. Good night.
Wow. Yeah, because the math all works out and it's totally scalable. It's just infinite in terms of the math and what you've essentially signed on to allow to happen, I guess. I mean, it's really low. Like Jay said, when everything's great, it's really low. When there's plenty of supply, I mean, we all took economics to some degree, right? It's supply and demand, like Jay said. And there were people just getting killed. I mean, I felt so bad. I read a few articles, and these are people that they can't afford to do that. Their businesses are going to go under because
some of these people were 5-10 G's a month, right? It was
they subscribed to it because they're looking for a cheaper electric bill, not because they wanted to get exposed to this kind of risk.
So just to dig in a little bit more, Troy, here, this is just there's obviously a couple of core kind of narratives in this story of what's happening. And really tragic stuff. I mean, it's hard to imagine. When we were creating the Pantech Design Minutes a year or so ago, we didn't think to ourselves, total grid outage, total grid failure, massive supply demand problem with wholesale electricity markets. None of those things crossed our minds, but this is what we're involved with. So you have the storm on Sunday. It had been frigid, you said. Then you had snow come down. Then you started to have problems with generation and substations, and the generation systems were going down, and people were expanding. I'm just recapping. You're expanding their usage, and then what happens? Do they get? It's cold. They're turning up their heat. So what do they? What happens? Do they get a message from saying, "Hey, there's going to be a brownout"? Do they get a message that says there's going to be a brownout and the prices are going to spike
blackout.
unless
Brownouts are low voltage. Blackout is just off.
Or a blackout. I mean, do they have a choice? Were they aware and cognizant of what was happening, or did they just get hit with a massive electric bill out of the blue and they had no idea? What did it look like for them?
Well, so we got to unpack a few things there, but let me address the first part about being notified. The answer is no. If anything, if you were notified at all, you were misnotified. You were told that something was going to happen and that you'd be back up and running, right? The problem is what they did was when they got down to about 2,500 megawatts in reserve, okay, that's when they said, oh my gosh, we're in trouble. They instituted rolling blackouts, but the issue was right when that occurred, they lost more generation. That's when we dipped into a negative. And just to give you an idea of just rough numbers, a megawatt can power about 200 homes, okay? So we're talking about a 2,500 megawatt excess, and that'll give you your rough math there, right? Well, where we got in trouble was when they did the rolling blackouts, told people, yes, your power is going to be out for a little bit. Don't stress, don't worry. It's all going to come back and blah, blah, blah. And then bang, bang, bang. We lost more unpredicted generation sites and some of this is coal and natural gas. I mean, close to 70%-ish, I think, no, 54%, I think, is coal and natural gas based power generation in Texas. And when you start seeing these things dropping offline, they had to keep people off indefinitely because we kept going negative no matter what they did. And the rolling blackouts weren't going to help at all. And then on top of that, again, a continual increase in demand. So one thing I can tell you is our typical peak demand, okay, is going to sit somewhere, and around this time, is going to sit somewhere around 60,000 megawatts, okay? Today, 72,000 megawatts. This is after everything's settled down and they will finally be able to bring everybody back online. And I think there's only like 150,000 people without power. But 72,000 megawatts, up 12,000 megawatts? That's insane.
Like a 20% delta or something like that.
Yeah,
right?
Yeah,
Gosh.
absolute craziness. So I got a quick question before we continue that line. I mean, you mentioned coal being a major component of this, and we talk about coal being noxious and bad and all this other stuff. That's the reason why we do solar and wind and renewables. But we do think of coal as the firm power option. How are these coal plants going offline?
Yeah, really.
Right. Well, I don't want to sound like an expert on this because I'm not yet, but I will learn. But I believe, so this is me saying what I believe. I believe it wasn't the coal plant per se going offline. It was the T&D, the transmission and distribution, that really caused the problem because we're not designed for negative 15 wind chill. Those systems aren't, they're not properly insulated for that kind of stuff. And so just like a water pipe, you envision what can happen to a water pipe that's not properly insulated and properly taken care of. I think that's where the major issues really came from. And that's why we had so many of our generation sites drop offline, and ERCOT couldn't manage it. I mean, it was, the variables were insane. And the only way that we could get ourselves back to good was to start from a baseline that we know. And that's when everything started to settle down and we started to sort of see that we were stable for a period, that they could then start truly instituting some of these rolling blackouts to bring people who have been without power back online. But then we even had more issues with that because they've been offline for or the homes had been dark for so long, and the sort of the T&D to the home and the transformers and those types of things had been offline for so long that then you had problems there as well when you try to feed power back in. And then you've got a whole balancing act that you have to do, which people don't really understand, that, you know, electrons are funny little things, right? They in order for them to flow distance and correctly, they need to be balanced. And
Right.
you've got this complete imbalance happening all over the place. It was nuts. And poor ERCOT, they're getting blasted, but maybe they should be, because the generation facilities need to be properly cared for with respect to what can happen. And that's what we all learned.
Yeah, yeah. It's a bit of a failure of imagination here across the board,
Yeah.
right? So, you know, it's for people that experience this. I keep thinking about the individual that didn't get a notice or got a little notice, and then all of a sudden they're out for longer than they expected. And then they try to bring them back on later on down the road, and then that's a conversation too, like we said. And I can imagine those metrics they're using to think about consumption are no longer quite accurate, so they can't quite balance generation and consumption. Probably is what we're discussing here. But that person that had that, do people typically have different heating systems? Do they have something that's non-electric to keep them warm in Texas? What's it like living there? Were people simply out of heat? Period. It sounds dangerous, and I understand there was some deaths associated with the storm too, which is tragic and terrible. So, you know, what did people experience?
Well, I can share a personal story. My parents called me up because they were out of power, and they had lost power the night before, I think. And he called me. My dad called me in the morning, so they've been without power for now maybe like 8 hours or so. It was about 58 degrees in their house, and my dad's like freaking out, going, "What do I do? Because my fireplaces won't work." Now the fireplaces are gas. Okay. And if we have natural gas, peace and love, man, we should be able to turn on the fireplace. But they were not able to. And the reason why is because of a simple thing. The builder did not put backup batteries, 2 double D batteries in a little thing in their fireplace, and their fireplace would have worked. And that could have kept them warm. But simple things. And so when you ask that question, Josh, there's so many little things, but what this really all comes down to is preparing for the worst. Like you just got to do things and know things to prepare for what could potentially happen. And you said it beautifully earlier, failure of imagination, right? We don't think this would ever happen. How could this ever happen? It's Texas. And no, man, it's anything's possible. And so what I think this did, and as bad as it is, and as hurtful as it is, there's a lot of people that have gone through a lot of pain, but boy, what a wonderful wake-up call for this state. And I truly believe that products like Adapt Energy and others are going to be looked at by the utilities, because this would have saved their butts. They need granularity in a demand response program that can shed load when they need to and as fast as possible. Okay, that's what needs to happen.
So we're going to dive into this now. And this is I'm excited to talk about the technology and the solution and what happened. But let's do this. Let's think about what happened in your home specifically, if we can, and then and then from there we could talk about how, if that were implemented on a macro level, what would have been different. And I think that's really and we know what the potential of this is because we've talked about it with you so much, but most people, they don't really have a good handle on this yet. What your technology does, what does a solar system look like? So let's just do a quick recap. What do you got at your home? What's there? What are the tools in place? And what happened when the storm hit?
Right. So let's start with solar. Love it. It's great. And happy to have it. solar does not work when there is snow on solar panels. All right, you're going to get, I mean, I can generate about 12,000 watts max from my system, or 12 kilowatt. And I was seeing with covered snow panels 100 watts.
Gotcha.
So solar's great, but not very helpful.
That's key. That's key to think about, right? Yeah.
It really is. Now let's exacerbate that with solar. Won't even work if the grid goes down if you don't have a home battery. You have to have a method of in some way to power the inverter in order to get that DC power to AC and allow that to run in your home. So a home battery. I have a home battery in my house. I chose Sonnen. It's a 20 kilowatt hour battery. Fast math. It can do 20,000 watts for an hour. It can do 10,000 watts for 2 hours. Then you got to focus on the inverter being able to only produce 8,000 watts at a single point in time, which means I can be full tilt 8,000 watts for roughly about 2 hours, 2.5 hours, and somewhere in between there. So already peace of mind, right? I know I'm going to be good with supplying 8,000 watts for 2.5 hours. Now we start involving adapt energy. What happens when we cut that 8,000 into 4,000?
You get extra time, right?
Close to 5 hours. All right. What if we cut that again into 2,000? What if we cut that down to 1,000? And that's what adapt energy really does so well, is it gives the system the ability to shut certain things down. And like I said earlier, your lifestyle really does change when you have to start focusing on the bare minimum. And I was able to deduce, by virtue of what was happening around us and doing some of the basics in math, that my system would allow my true basics to run for 30 to 35 hours.
Wow.
So I got to sit back, relax, and go, you know what? Worst case scenario, I'm good for a day and a half. And if they do rolling blackouts, I'm going to be able to charge back up and then, do that all again. So for me personally, it was a real non-issue. Now you want to hear I'll tell you a true story. That first night, I had a terrible dream. And it's going to sound really bad, and I'm sorry, but this is just the funny truth. The terrible dream was this: we lose power in the middle of the night. Okay. And I wake up and I walk to my front door, and I've got this lantern out front that comes out of the ground. It's a 3-post lantern thing, or 3-light lantern thing. And my lantern's all lit up beautiful, but everywhere else I look is black. My house is the only house on the street with power.
You had this dream on Sunday night?
I had this dream on Sunday night, but here's the scary part. This is the not so funny, scary part. There were hordes of people. All I could see was shadows, but hordes of people all coming towards my home. Whoa. That changed my power profile. You know why? Because I don't want my lights on outside. I don't want my lights on inside. I want to be candles only, because if I do that, I'm inviting literally the neighborhood, because they want to know, why do you have power?
Right.
And I don't. And desperate times call for desperate measures, and desperate people do crazy things.
Gosh.
So it brought up all kinds of different feelings for me personally. Even though I was in a good position, I was also, on one hand, very comfortable, and on the other hand, thinking about the what ifs, using my imagination.
That's remarkable, because I think that when we think about the battery backup technology, the industry, the emerging microgrids that we're incorporating into our homes, we often think about I literally have brochures, right? When I was back in the installation business, where we'd have a neighborhood, it was like a silhouette of like a cityscape, and then it would have a home, and it's glowing. You've seen that, right?
Yeah.
So, and then we think, oh, we're so proud because we took action and precaution, and we had foresight, but in that scenario, you're like, oh, I'm standing out here as a potential target. That's what you're saying, right?
You are a target in that situation when everybody's freezing their butts off. and you're sitting in your house,
Oh my goodness.
nice, warm home, yeah, you're a target for sure. And I think it was sort of maybe a way to wake me up a little bit, no pun intended, and think about like, hey, wait a minute, man, maybe you shouldn't during grid loss have your lights on and
You want to
and the light
showcase that. This isn't the time to
showcase
showcase
that.
that.
Yeah.
Yeah, the time maybe to showcase it is during education, or what we're doing right now. We're having a
Right.
conversation about, hey, let's get ahead of this and learn from our experience. Yeah, it's just it always strikes me that you have to go through something to really understand the full consequence and full kind of impact of the technologies and solutions that we're working on building, and we get a such more in-depth picture when we go through the reality of it. There's
Yeah.
just no substitute for that. We get great imaginations as human beings, but at the same time, it's really tough to get a full picture until you're there. Okay, so you got this system, you have the solar's not working with snow on it. That's a no-brainer, right? And you realize that you could you could really manage your loads down to a minimum, a bare minimum, and get a day and a half of overall power for yourself there. Do you see yourself wanting? Like, do you use a generator right now, and do you see yourself wanting to use a generator in the future as a backup for your batteries? I mean, that's just something that occurs to me. We talk about that a lot.
Yeah, I think there's a place for it, because if I had a generator, it's just further peace of mind, right? Because my battery can only last so long, and depending on how you design the system, and the way I would personally do it is I would have the generator actually charging the battery.
Yep.
Because only makes sense to me to do it that way. But if you're sort of toying with the idea of generator versus battery, lots of pros and cons, whatever. But at the end of the day, I think you're best with home battery and a generator. And the other thing is, you don't necessarily have to do a really, really large generator. And you've got options there as well, natural gas, propane, diesel, so there's plenty of different options there. My father and I had a deep discussion about this. He asked me point blank, son, how come I don't have a generator?
Wow.
How come? And that wasn't pointed at me per se, but it can only be asked of me because of what I know and what I do. Right? He's my dad, my mom and dad. Why don't I have a generator? And because I goofed. I didn't think that I didn't think you guys would ever be in this position, sitting in your houses with no fireplaces working and no heat and no for a day and a half, like. Wow. So yeah, we're going to do that. So having a home battery and a generator, I think, makes a lot of sense, because they can work together in concert if you design it the right way, and one can help the other, and you can also sort of handle extended outages in a much better way.
There you go. And what I want to do is I want to recap that a little bit here, thinking about the individual home and the benefit and the different systems. But I also want to then move into a conversation, if we can, about how you can actually, being let's say an energy independent home, potentially in the future actually help the grid and help minimize some of the problems that they encountered, right? So there's a two-pronged approach here. Now, when we look at the home, and I'm in the process of designing and installing a system on my home, have the solar in, but I don't have the batteries in yet. That's happening now. And then, but what's really interesting, I think, about this, the home concept is, on the one hand, you have production, and that's basically PV. That's your solar. And you could potentially have other sources of production. You could even have a little windmill maybe, or something like that. I got a friend of mine who lives in Iao Valley. Kai Noah is his name. Good friend, great guy here in Maui. And he has a little water turbine. It's like a camp kind of version. He'd like to have a bigger one. We were talking about that. So you could have different sources of production, but for 99.9% of people, it's going to be solar, right? And then if you add in a generator, they're not super expensive these days. You can get one at Costco for $600-700. And some of these systems will actually work with that generator, which is very interesting. I want to talk about that. So you put in a generator. Now you've got an alternative generation source. That's a very valuable and very inexpensive step to take. So to me, it's like, that's kind of a no-brainer. having a generator around, right, to protect yourself. But once you get into the point where you have your PV, you're saving money, you're being green, right? And then you put in a battery. Now you're in a place where you have the longevity that you described. Maybe you've got 20 kilowatt hours. Maybe you've got a Tesla Powerwall. Maybe you've got a Sonnen. Maybe you've got an LG Chem. Jay, I want to mention all the rest of the guys that have been on the show over the years. The Panasonic Evervolt, you name it, right? They're all these great guys that are out there working on all these technologies. So generally, you're looking at 10, 20, maybe 30 kilowatt hours in that kind of range. And you described, Troy, the longevity you could get out of that. But in the absence of having some form of management of the consumption, you're going to pretty much discharge that energy, maybe, or maybe you're manually popping off switches or whatever. But in in an emergency situation, you want to be figuring it out. You want to be like, okay, now that my life is in peril, let me figure this thing out. It's the wrong time to be thinking about that. You want to have that worked out in advance, right? So in the case of Adapt Energy, which is so great about it, explain to people exactly what it is, because we're talking about a smart panel that controls and moderates loads, so it makes those decisions for you, right?
Yeah, it absolutely does. So the idea is to think about it in terms of levels of severity, right? And I mean, this level of severity was max, right? The you want just the essentials. That's it, no more, no less. So what Adapt Energy does is it gives you this first level of severity, which is what you have to shut down, like what your battery or your generator maybe can't possibly power, and you wouldn't ever want to power anything.
The luxuries, right? The hot tubs,
the hot tubs, like the pools, you got it.
Clothes dryer, probably.
Yeah, exactly. Who's doing their laundry when we're in a situation like this?
I'm wearing sweats all day long. I'm good.
Yeah, exactly. I mean, so that first level is your default. What do you have to shed or get rid of in terms of load? And then you have these other levels, and Adapt Energy provides 3 other levels that you can sort of predefine that gives you a range of sort of based on state of charge of the battery. It gives you a range of how long you can sort of last, right on battery power. And I did this already because I obviously put my own system in, and we would do this we train people to do what I'm about to explain, but you sort of take some law of averages against those levels of severity. We call them power profiles, and those profiles you get to choose from at any time, but you're also presented with those right when the grid loss happens. And so it's very feeling based, but it's feeling based with information. Wow. Right? So you're able to look at the system and go, you know what? I feel like this is the big one. I'm going to say essentials only. And I press that button and boom, I'm in the best possible scenario to make my battery last as long as possible. Right? So that's just one way Adapt Energy manages that.
Now it's still configurable after the fact. I mean, I remember you talking about the garage door story at one point. That's right, that's right. For those that don't know, someone had set up a power profile and had forgotten to actually add their garage door. Now this is a system where you can control it through your mobile phone. So you're out and about, you get the message and you lock down the home, just as you say, and then you get home and you can't open your garage door. So he was able to actually add that back into the system after the fact.
Yeah, on the fly too. On the fly, Jay. I mean, you whip out your phone and you go, oh, I shouldn't have probably had that off. Or,
why isn't this working?
Yeah, right. I can't get in. I get, Or how about, you know what? I do want to take a hot shower. And you know, it's dynamic, right?
Yeah. Yeah, but it's such a very different system than like your average critical loads panel. I mean, that's what people generally think about when you're getting a home battery, is you basically have to make a decision when you install it, because you're going to have this electrical panel that is your everything that you absolutely need when the power goes out, and you have this whole other panel that is all the ancillaries, and that whole panel just shuts down. There's no way to connect the two after the fact. So right. Very, very different. Than
we like to say that Adapt Energy changes the design principles of a home battery and energy management system in the home, because so much you get to decide on so much after the fact. And then the other thing, right, that I experienced that I hopefully conveyed well, is that the circumstances change. Lifestyle is different under those conditions. You think you set this thing up the way you think you might want it, but no, I actually had 2 other loads that under duress, like, no, man, we're good. Like, I don't need those, So, and I was able to on the fly handle that if I wanted, So it's very, I guess I can say we're true to our name. Right?
That's that. I mean, the other situation I can think of is after the fact. And you said even if you were on critical loads and you had like only a few outlets that actually worked in the home, I can imagine a scenario where you shut everything down or everything shuts down and you think you're good and you walk into the other room and the kids still they found the outlet that works and they're still sitting there playing their video games, sucking away your power. Like, no, go read a book.
Well, you touched on something really, really kind of smart that I use in a lot of my sales stuff is that we're almost protecting ourselves from ourselves, right? Mm. We shut down the washer and the dryer because, it's kind of weird when the power goes out and you still have power. At first, it's like, oh, wow. And then maybe 30 minutes, an hour goes by and you're back to normal, man. It's just, right. You're just rolling and let's go do some laundry and go do, if it's on, you're going to do it because, well, that only makes sense, right? It's the way, what you're used to. So it kind of puts you in that position where it's like, oh yeah, I should not do my laundry right now.
I think that's a great opportunity to talk about the generator, right? So when you go through that experience, and you learn a little bit about the loads that you actually need, and you're on ultimate austerity mode, right? Like the number one kind of curtail as much as possible mode. But then if you have a generator, what's remarkable about this, and people may not be thinking about this, but you could potentially use your generator to power your whole home, but you have those loads are very low, right? And firing on a generator is as I understand it, a very inefficient method of meeting those small loads, right? So it's like you could now fire up a generator, and you mentioned it, repower your battery once it's discharged, and then be able to continue to extend your grid, your energy independence for quite a long time, as long as you have fuel. But I mean, it's a really remarkable kind of a solution that provides real resilience. I mean, is that kind of where you see things going?
I do. I think that one of the things that my Sonnen battery has, and what they did really well was this exact concept of allowing a generator to not only charge a battery but also power a load in the home as well. And so you like you said, it creates this it's indefinite depending on the type of generator you have. If you have a natural gas generator and there's natural gas, you could be days and days and days and days and still be okay. I mean, what we need to start doing is it kind of goes against what might make sense at first, but I believe that we should be building our homes differently, and instead of building them to be connected to the grid, I think we should be building them to be off grid first, and then start to look at the grid as the secondary, right? Because if we start doing that, we're going to start becoming much more conscious of our energy and where it's coming from and how we're using it. And it's a system like Adapt Energy that's going to help really make that happen. Something that can manage it for you. And I'm going to use my wife's words with me. She says, honey, I love our system. It's great and everything, but there's lots of bells and whistles and things. I just want to know if I'm winning or losing. Wow. And it gave me cause for pause because I like all the techie, cool, fun stuff, but she wants to see this nice little sliding scale thing that just says it's green or red. I'm winning or I'm losing, and that's it. It's a really simple but pointed concept of how we I believe will be living our lives in the future with respect to energy in our homes.
It's so interesting that you bring up the green or red thing, because as you were talking, I was thinking, Jay, about our friends in Osaka that were manufacturing home battery systems, and they had a little a very Japanese display, and they were marketing them here in the US. Do you remember, Jay? And
Hmm.
at one point I had it on my home in a mobile trailer, and I would for fun turn everything off and then just run off of the mobile trailer and see how long we could do it, right? But it would had a red and green button, and then the way the CEO described it, and it was kind of like, imagine a home, a mom, dad, a couple kids, and the game was to just be in the green, and it was that
Stay green.
simple, and it was
Stay
so
green.
yeah, very,
Gamify that whole thing. Yeah.
yeah, very
Totally
interesting. So
could.
we like the tech. We're us geeky guys like us can
But
really
also,
dig in
but it
and
also plays into what Troy's talking about. Also plays into that whole the DC ification of the home. You know, we have so
Mhm.
many of those little power bricks, those wall warts. If you ever touch those things, you know they're warm. That's
Mhm.
wasted energy.
Anything
And
heat is wasted. Yep.
yep. So that all of that stuff, it really adds up if you have like just this parasitic load in your house at
Mm.
all times. And so there's a big push, at least on the fringes, to totally change the way. I mean, AC is still going to be the only way to get long-term transmission. That's the whole
That's the reason why we have it. Yeah.
AC/DC from way back when. But in the house,
Mm.
you can pretty much everything we run off of is all DC. And so doing DC wiring instead, if we took that leap, the efficiencies gained could be tremendous.
So if you guys have any influence in this area, and I bet you do, I have an idea for somebody.
All
I'm
right,
focused
let's
on
do it.
mine,
Let's hear it. Let's hear it.
but the only way we're going to get there, the only way we're going to get there is to allow builders and developers peace of mind with the buildings that they're building, and create a copper, basically Romex, that allows for AC and DC. And they're two separate wires in one jacket.
Whoa! So the entire home is hybrid.
That's right.
Whoa!
That's what it's going to take. And I think you do that, and you do it at a reasonable price, because copper is a little expensive. But if you can figure out how to do that, you're going to get the builders and developers wiring homes, because that's what's happening right now. They don't want to mess with it, because they don't want to get, shafted on the backside, right? So if you can wire the home, do the infrastructure for either or, and even be able to do a hybrid at the same time, now you've got something big.
Check that out. I know the hybridization of the grid has been a talking point, kind of in the very I don't know what to say, kind of like, I'm gonna use the word geeky again, kind of geeky enclaves of SPI over the years. It's been, the hybridization of the grid. Jay, come on, you know what I'm talking about. And in
I know
that
exactly
world,
what you're talking about.
there's this discussion and just really interesting language, very philosophical. I'm gonna borrow some terms and phrases. Jay can probably imagine what I'm gonna say,
Mhm.
but the flourishing garden of smart devices are all DC, right? So you have all of these throughout the home, and then meeting them with this kind of inefficient AC/DC rectification process is just not a great way to go about doing
They're
it.
all
And as,
super low voltage too. I mean, microprocessors generally 3.3 or 1.8 volts
yeah,
coming
Less, yeah, yeah.
from a 120 volt AC source. I mean, there's a lot of step down that needs to happen there.
with
Yeah,
the
and,
car,
and
with
so
the
much
cars,
loss.
with the cars, we're in a place where now we're going to start to see some really substantial loads and
Yep.
voltages that can be powered via DC. You look at Osiaco out of Montreal; they're the first home DC charger from an inverter, right? So I mean, there's a lot of legs in this conversation. I'm very excited to hear about it. Okay, so maybe we're talking about hybridizing homes and providing it through one of these technologies. Who knows?
I do want to point out one thing though, and there's the reason why I'm kind of a champion of the microgrids is that you do build your house as a standalone unit, and that's fantastic. But what if you have an equipment failure problem during an emergency like this? And that's the reason why I'd like to be able to lean on the neighborhood. The grid has a place, and I think the place is to share amongst the
Mhm.
neighborhood at the very least, just to make sure that if there is a serious issue like what Texas is going through right now, and one neighbor, elderly couple down the way, wasn't really paying attention, their battery was flat, and it is now defunct, they will still be protected because the neighborhood steps up. That type of microgrid infrastructure, I think, is what needs to happen. It cannot be, well, we'll just make all standalone homes and grid defect. It needs to be a community effort.
Well, if you
Yeah, levels of that, right? I love that because your first level is self-defense, right? You're doing what you've got to do for you. But just like happens, especially in Texas, people help people. And if
Yeah.
we could do the same thing with energy, why not? You know, I would have no problem at all giving power to somebody if they need it, right? Like that would be a no-brainer for me. And under these conditions, I would have loved to have sort of shared the wealth, right? Like given my neighbors, great, I can't go 30 hours, but you know what? We can have 3 families that can go 5 hours.
Yeah. And I don't even
Fantastic.
think it would be at that level. I mean, even if you have 1 out of 100, the draw on your
Sure.
battery is going to be negligible.
Right,
You're going to
right,
really
right,
even
right.
notice.
So if we think about so now we've kind of painted a picture of what happens when there isn't this type of planning, what happens when there is this type of planning in the case of your home and your technology, and then what does that mean for the overall grid in the future? Because now we go back to the grid operators, and they were in a situation where you had rising demand, you had diminishing supply, you had all of these weather conditions creating all these different problems. What does a scenario look like where the bulk of homes, let's say 20, 30 years out, have some degree of their own power on hand, or very resilient, or very efficient? We're talking about grid services. We're talking about the value stacking of batteries. Can you
Mhm.
imagine a world like that? Would that minimize? I mean, it seems like it would, but any opinions either from either of you guys? I mean, is there any? Can you see that world? Can you see it better than me? Because I'm trying to see it. I'm like trying to peek to see that world where it's safer, and the grid operators are able to manage those assets and pull from those batteries, and tens of thousands of homes have a little bit of excess power, and it can be moved back and forth as part of the grid. I mean, can you see that world in front of us?
Absolutely. I think 100%. Yes, we have. In my opinion, we have to get there. We don't have a choice because the likelihood of us completely redoing the grid infrastructure in the United States in the next 50 years is pretty slim. We're going to make modifications. We're going to make band-aids. We're going to make things a little better here and there, and we don't have a choice there. But think about what you can do in 10, 20, 30 years if we sort of take an outside in, or it's more, you could even say inside out looking approach, right? Because it's more outside in right now. The grid gives your house power. That's it. That's the way it works. And, if it doesn't have power, then you don't have power, Well, if it's the other way around, and sort of like Jay was saying, like, look at neighborhoods. First, focus on the home, then focus on what the neighborhood can do together. And then maybe you can even take it even a step further and have multiple neighborhoods. And, all of these things can work together, and the grid becomes maybe a secondary approach. Because I see things able to do this a lot more, especially now after having been through this whole COVID thing, because we can do this so fast. Look at what you and I are getting to do right now. I mean, Jay, you're in Japan.
Yep.
Josh, you're in Hawaii. I'm in Texas. This is instantaneous happening right now, right? So do I need to drive an hour to go do something anymore? Not really.
Yep. Yeah.
Everything's going like this. And we're going to have this community, and it should involve our grocery stores and our hospitals. And all of these things are going to be a lot closer to us. And I think that's the way I see the future going, because I
Yeah.
think it needs to.
Yeah, it's really kind of a special time, and coming off of these adverse experiences, be it COVID, the last year, we've all been through this just a completely new type of world, and the storm that you're talking about here, it provides you with an opportunity to look at it and say, hey, there's other possibilities here. We can live in a different way, And then I do want to touch base on some things that are actually happening right now that are kind of related to that aggregation, and this is still utility centralized in a sense, but you have virtual power planting contracts being written. I was at the Clean Energy for Biden event, and just talking with people there, which was like an online virtual event, not a month ago, on the 20th, I think. And I met a couple of companies that had just been awarded contracts in Maui County for virtual power planting. And what they're doing is they're aggregating Resi and CNI clients, commercial, industrial, as well as residential solar plus battery clients, to and solar clients just alone, to be able to disperse that energy and move that energy around, I suppose, and so the utility has some access to that. So that's actually, it's not like it's science fiction. These contracts are being written, these technologies and softwares are being put in place to be able to provide greater resilience. And if you're the grid operator and you have, I suppose, a VPP like a Soleil Lofts, let's talk about some of the amazing projects that Sonin and you yourself and Pantech have been a part of putting together. But these types of systems where you've got hundreds or thousands of units, and that they're let's say 10 or 20 kilowatt hours each, and before you know it, you're into megawatts, and then or megawatt hours of deployable energy or megawatts of deployable power, and then a grid operator can say, hey, yeah, I've got coal over here, and I've got these different gen sets, and I've got wind over here, and that's a small percentage, but we also have, this pretty substantial resource to be able to call upon. I mean, that is happening at the moment, and it's a pretty radical time to imagine that being in place. I was just,
and picture the utility having options, right? And what they're going to choose if they do, and having those virtual power plant options. The more that pop up, the less we're going to be using peaker plants, and the less they're going to choose some of those other generation mechanisms, because on the one hand, one's clean and the other one's not. I mean, it becomes pretty simple at that point in terms of the decision making,
Yeah, right now the only other option they have is to shut you off.
Right.
Which is what happened.
Not a very good option. Now, I do want to ask you, Troy, because you always seem to have a surprise for me whenever I talk to you. So last time we spoke, I know, I want to say SPI 2019, we were looking at Soleil Lofts. And just for everybody, that's an amazing development. Check it out online. You're talking about solar plus storage in hundreds of these beautiful condos in Salt Lake City, Utah. That was deployed, and the whole project was a Sonin or a New Energy Partners project, right? And a really remarkable type of virtual power planting project, an example, a real world, literal example of what we're talking about. And I know you mentioned that there was some real excitement and new types of projects being agreed upon. Is there anything you could talk to us about? Tell us about some of the ones that have actually kind of any pen to ink going on there? I mean.
There are, but I can't tell you, I can't give you the names. I can tell you that batteries are being sold in the thousands, and a new company was formed for the purpose of that, called Pantech Logistics, and there's a lot of neat things happening there. So you're right. Every once in a while, I do have a surprise, I guess I can share. So yeah, that's something that we work with Sonin very, very closely on. And it's tied to some of the developers who were involved in Soleil Lofts and the like. And there's probably about, I think I'm aware of maybe 7, 8 different virtual power plant opportunities that are being looked at. And 2 of which have already been inked, and the others are still working. I mean, the biggest challenge with the whole virtual power plant thing, to be honest with you, is it's twofold. It's the utilities, and it's the raising of capital. Because they're long-term plays, right, on this stuff, and the utilities got to be a big part of it in order for it to really, really work. And so there's definite challenges there, but also some really great stuff coming, and we are definitely helping in every way we can.
So that is an example, folks, of some pretty dynamic and creative thinking, but also some very real-world, large-scale deployments of solar plus storage that could act in the capacity that we're talking about. If you think we're talking philosophically,
and the adapt energy system.
And the adapt energy system. Yeah, man, it's just amazing. All right. I think we've covered some great ground today. I'm so glad that we had a chance to speak with you, Troy. So good to see you and understand what your experience has been. Some amazing stories. Jason Verkart, would you like to add anything to the close of this show before we wrap it?
Troy, where can people find you?
You can find us at www.pantechdesign.com. And of course, your typical social media outlets, with Facebook, Instagram, and Twitter. Just look for the Pantech Design name. And you can also Google Adapt Energy, and you're going to see a lot of neat things there too.
There you go.
Excellent.
Folks.
Thanks so much for that. Check us out, solar-coaster.com. Of course, wherever you're watching this particular video, hit like, subscribe, feedback, thumbs up, thumbs down is very important to us. And do comment, keep the conversation going.
All right. And I'm just going to close this show with an Aloha Friday, because it's Friday and it's 2 p.m. at the end of our usual radio hour. Very good, Jay. Thank you, Jay. Thank you, Troy. Aloha, guys. Have a wonderful weekend ahead.
Have a good one.